We're going to look at today the concept of conditional probability, the chances that something happens given that something else happened before it. Now, we've already kind of seen this notation in yesterday's video with dependent events. This part, the probability of B/A, that's the conditional probability, the probability that B happened given that A happened, or the probability that B happened if A occurred. So if we're trying to figure out how much this is, the probability that B happened given A, we can use algebra to transform this formula around. So I want to keep this part and get rid of the probability of A. Well, the probability of A is attached to the probability of B given A by multiplication. So if we divide by the probability of A on both sides, that's going to give us our formula to use. The probability of B given A happened is the same as the probability of them both occurring, probability of A and B, divided by the probability of A. Now, as we get into some problems here, you're just going to have to figure out what you're using as the A and the B. One thing to help you out in terms of the word problems is this line here, this slash between the B and the A. Some cue words that you can use to help you out are given or if. So if you see one of those two words, that's your condition that you're going to be working with. So let's start with our used car lot here. We've got 100 cars in the lot, 20 have manual transmissions, 50 have sunroofs, and 8 have both. What percent of cars have sunroofs given that they are manual transmission? So that last sentence is telling us what we're trying to find. What probability or what percent of cars have sunroofs given that they are manual transmission? So now looking at my setup up here in black, I know probability of B is sunroofs and A is manual transmissions, just lining that up there. So now I can set up the other side of my equation in words. Probability of manual transmission and a sunroof divided by the probability of A, which is a manual transmission. And once we have those words there, then we can start to plug in numbers. So the probability that a car has both a manual transmission and a sunroof is right here. 8 out of the 100 cars, or 0.08, or 8%, whatever you want to call it. And then the probability that a car has a manual transmission, well, 20 of them have manual transmissions, and that's 20 out of 100, or 0.20, or 20%. And then we simply divide 0.08 divided by 0.2 and get 0.4, or 40%, if you want to change it into a percentage. So 40% of the cars have sunroofs given that they are manual transmission as well. And without doing all that probability stuff in there, that really should make sense in terms of if I'm given a car with a manual transmission, which I know there's 20 of them, how many of those 20 have a sunroof? Well, 8 out of the 20, and 8 out of 20 is also known as 40%. Now let's come down here to the bottom. The drug situation. So it says in the last sentence, what is the probability that if a patient with the disease takes the drug, he or she will recover? So that if is right here. if the patient with the disease takes the drug, what's the probability that he or she will recover? So my B is going to be recover, my A is taking the drugs. So over here in words, this is going to be A and B, recover and drugging, divided by the probability of A, which is drug. So in the problem, let's see if we can pick out the probability of recovering and taking the drug. That's in this sentence right here. You know 5% of the patients are both taking the new drug and recovering. So my numerator is 0.05. And my denominator, the probability of somebody taking the drug, is right here. You also know that 20% of the patients the clinic's seeing are taking the new drug. It's 0.20. And then if you do 0.05 divided by 0.20, you will get 0.25 or 25%.